Hello, welcome to our next video on similarity, and today we'll be using proportionality theorems. So our target is to use proportions with a triangle or parallel lines to find missing lengths of figures. I'll start off with two theorems, actually one theorem and its converse. Our first theorem is the triangle proportionality theorem. It says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So for example, in this particular case, if I have, we're given TU and QS are parallel to each other. So here's TU, here's QS, they are parallel to each other. And what this is going to do is this is going to divide this triangle proportionally, such that RT over TQ is going to equal RU over US. And then the converse of that theorem would be if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So in this case, TU would be dividing RQ and RS proportionally such that RT over TQ equals RU over US. Therefore, we can go ahead and say that TU is parallel to QS. All right, let's go ahead and apply the first theorem here. So we are given in this diagram that QS and UT are parallel to each other. So because of this, as we say, it divides the two sides of the triangle proportionally, so that RQ over QU is equal to RS over ST. Now what we'll go ahead and do is start substituting number values here. And we're given that RQ is 10, so we'll plug that in for RQ. QU, this is what I'm trying to find out, so I'm going to go ahead and call that X. Equal to RS, which we're given as 12, over ST, which we're given as 6. We can go ahead and cross multiply, so 10 over X equals 12 over 6. Cross multiply, 12 times X is 12X. 10 times 6 is going to be 60. Divide both sides by 12, and X is going to equal 5. So in this case, QU is going to be 5. Now, for this next theorem, go ahead and cross off what's written here. It's just, and you have to rewrite this one. This was accidentally copied and pasted twice. So the theorem should be what's outlined in yellow here, and that says if three parallel lines intersect two transversals, so your three parallel lines in this case are going to be UV, WX, and YZ. Those are my three parallel lines. You can see they're all marked as parallel. Intersect my two transversals. So in this case, my transversals would be line L and line M. Then it's going to divide those transversals proportionally. Okay. Specifically, you're going to have right here UW, which is right here, over WY, which is right there, is going to equal VX over XZ. So you need to pause this to make sure you write this down. You can go ahead and do that right now. All right, so again, this is an application. Example number 2 is just going to go ahead and use that theorem that we just talked about. And in this case, we've got a farmer's land divided by a newly constructed interstate. And the distance shown is in meters. Find the distance CA between the north border and the south border. Okay, so what I'm looking for, my final answer is going to be from here all the way to there. So what I'm missing right now, we're given AB as 2,000. Okay, we're given FE as 2,500. We're given ED right there as 3,000. I'm missing BC, this spot right here. Once I can go ahead and find that, then I can find the length from C all the way to A. All right, so we're given that AF, BE, and CD, which represents my north border, my south border, and my interstate, those are all parallel to each other. So that means that all these are divided proportionally. So my parts are going to be AB, which is the top part, the part between the interstate and the north border, over BC, and that's going to be equal to FE over ED. And again, we'll go ahead and we'll plug numbers in here. Okay, AB is 2,000, so plug that in for AB. BC we don't know, we'll call that X. FE we're given as 2,500, and then ED we're given as 3,000. and we just have a proportion, so we're going to go ahead and cross multiply. So 2,500 times x is going to be 2,500x, and that's equal to 2,000 times 3,000, which is going to be 6 million. Last but not least, we want to get the x by itself, so divide both sides by 2,500. Which is going to give me 2,400, and that's going to be in meters, where distance is shown as meters. So x from B to C right here is going to be 2,400 meters. Now that's not the answer. What we're looking for is the distance CA from the north border all the way down to the south border. So we need to take BC, which we just found is 2,400, and AB, which is 2,000, add them together, and CA in this case is going to be 4,400, and again that's going to be in meters. All right, our last theorem on here. Now, this one is not in your notes. I apologize for omitting this formula, so you can go ahead and write this down as well. This is going to be similar to another proportionality theorem. And this one's talking about if I have a ray, so in this case, CD is a ray, okay? And that ray is bisecting the angle. So angle ACB here is being bisected, meaning it's being split into 1, 2 congruent angles right there. So CD is an angle bisector. And what this is going to do is it's going to divide the opposite side into segments. So the two segments it divides it up into would be, so the bisector is here, so AD and BD would be those two segments. And those are going to be proportional to my other two sides of my triangle. So in this case, CA and CB. Okay? So again, it reads that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So specifically, we've got AD over DB is equal to AC over CB. Like I said, take a second to write this down, and we'll do an example of this. So we've got, we're given that DEG and GEF are congruent, making EG an angle bisector. So this is going to go ahead and follow the formula we just talked about. So given the side lengths, we're going to go ahead and do the ratio here. So we'll start with this side right here. So it's going to be GF, which is the right side of the side that's being split up, okay, over GD is going to be equal to now my other two sides, which is going to be EF over ED. So this is my proportion. So this is my ray that's doing the bisecting, okay? So it's going to be GF over GD, that's my first ratio, is going to equal EF over ED. That's going to be my second ratio. So let's go ahead and substitute numbers in here. So GF, now we don't know what GF is, okay, but I know that DF is 14 and DG is X, so that means that GF is going to be whatever 14 minus X is going to be. So we're going to use that. We'll say 14 minus X is going to be the length of GF. Now GD is given to us as X, so there's my first ratio. Second ratio is going to be EF, which is 12, over ED, which is 8. So we'll go ahead and cross multiply. 12 times X is going to be 12X, and that's going to be equal to 14 minus X times 8. Now remember, it's going to be 8 times parentheses 14 minus X, which means I need to distribute. 8 times 14 is 112, minus 8 times negative X is going to be minus 8X here. Then we get all of our X on the same side, so I'm going to add 8X to both sides. Those will cancel out. 12X and 8X is going to be 20X, equal to 112. Last but not least, divide by 20. And X is going to equal 5.6. So now I was asking to find the length of DG. That's what it asked me to do. DG is X, so we're done here. So x is going to equal 5.6 for this particular problem. All right, so go ahead and try the you try nows on your own. Check your answers. As always, if you have questions, please write them on the side and ask them next time you see you. Have a good day.